Welcome to today's FDTD Goes Applications webinar. Today we're pleased to have Randy Bowers from WFO Norman joining us, and the title of his presentation today is The Importance of Mesoanalysis in the WFO. He'll be looking at the May 22nd, 2020 tornado event down there. Next slide. Just a few things to discuss here before we begin. First of all these are recorded and made available on the visit web pages at the URL that's shown here. If you're interested in leading one of these in the future, you can contact either myself, Dan Bikes, or Scott Lindstrom. Next slide. And we'll give about 20 minutes for our speaker. If you have questions, you can either put them in the go to question box, or we'll have a Q&A period here as well. We'll be done by 20Z. Remember, don't press hold, and remember to mute when you're not speaking. So at this point, I'll turn it over to Randy.
All right, thank you, Dan, and I appreciate the opportunity. It's really exciting to be able to talk about mesoanalysis and some of the new ways that we're really trying to integrate the new technology here. You can see in the bottom left of this title slide, we've got Vivek that's working with some of the folks at NSSL on the storm scale modeling. It's one example. We've been really trying to integrate the Warn-On forecast system into mesoanalysis too. But the traditional mesoanalysis really, I feel like it has its roots in satellite meteorology. So much you can see from satellite meteorology, and we'll talk a little bit about that. I have an excellent case that sort of demonstrates that. So we'll start off, this was back in May of this year, and it was a scenario where we had a shortwave trough off to the north in the central plains, and as it moved off to the northeast, we kind of ended up in this area where we really we didn't have a lot of forcing for ascent. Most of the forcing for ascent had contributed to thunderstorm development earlier on the previous night, and it moved into northern Oklahoma. And we ended up with quite a bit of wind in northern Oklahoma as it progressed through. The day two outlook the previous day really highlighted the area from eastern Oklahoma and down to the south across North Texas. And they were trying to capture the morning potential and also the ongoing morning potential, and also the redevelopment that would occur in the afternoon. Tough forecast, really, but the SPC, they always provide excellent guidance that we can then begin to downscale at the WFO and communicate that. But they mentioned these high tendencies were rather neutral, so we weren't looking at a strongly forced event by any means. There was a lot of instability going on, or that would redevelop in the afternoon, and that was going to be key, along with the convergence along wherever the boundaries ended up being, the outflow boundaries. There was some indication that this would probably all come together for the redevelopment in the afternoon near the Red River Valley area, kind of in our North Texas counties that we serve. And so it was a challenge to try to pin all that down and kind of watch it evolve in the observational data throughout the day. Anytime we're dealing with the outlooks from SPC, it's sometimes when you have the morning ongoing events that crosses that 12Z early morning break period between, say, their day one and day two outlook, then there's an opportunity in there to sort of clarify that may be trying to capture two events. So we did that. We tried to message that by showing that we would have a severe weather threat overnight, the previous night, that would probably weaken as it moved towards the I-40 corridor, but would still be somewhat of a concern after 3 a.m. up until about 8 a.m. or so when we expected it to push out. So kind of key there is taking some of that model data and our forecast and summarizing it up into a graphic. Very important to try to find how to translate all the science into messaging. But the outcome from the morning event was that we had several wind gusts that were over severe criteria, especially over north central Oklahoma, and including the 81 mile per hour wind gusts at the Mesonet site in northern Logan County. So then we're in a situation by about 6:30 or so in the morning. This is all kind of moving through pretty fast, and we know that we're going to have to shift the message around just a little bit and start to de-emphasize the early morning concerns, since it's now pushed over into Tulsa's area, and really start to emphasize kind of that we're really going to have to watch the observational data closely. There's a lot of uncertainty about how things will evolve in the afternoon. We wanted to get that out there early and put that into NWS chat for our media partners and for our emergency managers, so that they could kind of get an idea of what may be to come. We updated that within a couple hours afterwards and really talked about how there's still a lot of uncertainty with the high-res guidance that may be playing catch-up in this scenario. That's pretty typical when we have these morning MCS. A lot of times we have a lot of convective overturning. The boundary layer sort of changed a little bit. It takes some time for the high-res guidance to really catch up to that. So it's one of those things that you almost have to kind of let go of the high-res guidance to a certain extent and really focus in on observational data, and that's what we're doing there. We're communicating kind of our strategy for doing that. I know there's a lot of text on the screen, but I think it's important to kind of highlight a few key points, what we're putting out through NWS chat, that we were watching for the potential for some further development that would occur, down to the south, and that we may have to really adjust the forecast and really focus in on the area that we expect to be a fairly small area later in the day. So hopefully this loop shows up fairly well on your end. I know GoToWebinar usually does a pretty good job as long as you're not too fast at the loop speed, but this is early morning through about 15:30 Z. And you'll notice that there's a lot going on here. Obviously the anvils and the high level clouds for the convection. You can see the deeper convection now moving into Springfield's area and over into the eastern part of Tulsa's area into Arkansas. And we're clear for the most part across a large portion of our forecast area. There's some mid-level convection that's ongoing in our southeast counties, but there's a lot of activity as far as undulator bore type gravity waves that are emanating from the early morning convection that have made it all the way into our Texas counties that you see. Let's see if I can show the highlight a little bit easier here. So yeah, this area right here, that was kind of our concern and the greatest uncertainty, but the greatest potential for some fairly high-end severe thunderstorms to develop later on. So, surface analysis can be kind of controversial in some sense. A lot of people, they may put a lot of time into it. Other people may sort of just try to basically absorb the data by just looking at the surface plots and not actually drawing anything out. I'm probably somewhere in between. I like to integrate the satellite data. I think it's very important to try to find these features in satellite and then maybe just sort of sketch them out on a surface map. So this is kind of one method that I've used to do that. In this case, you see the synoptic boundary that's across northwest Oklahoma. Surface low across the southeast Texas panhandle and trying to highlight out where the cold pool is from where the convection is most vigorous to the east and extending down into North Texas too. And then the sharpening dry line across Lubbock's forecast area. And really we started to get a clearer picture of what would happen by the time we got into, say, the late morning, midday time period. We were able to really put out some more information and start to apply those conceptual models. We knew at that point that the models, the high res guidance and some of the cams were not really catching on to exactly how things would play out. There's a lot of diversity in what the cams were showing as far as where the convection would develop, how intense it would be, what the convective mode would be. But we used some of these conceptual models to really pin down where this boundary, how it may behave. We knew that the pressure tendency suggested that the eastern extent of the boundary would continue to move to the south, whereas the western extent would stall and possibly even retreat back to the north a little bit, move northward later on in the afternoon. So we were really trying to pin that down and try to provide some information on the timing of the convective initiation. Even a big part of this too is a collaboration aspect of it. We were talking with SPC, their expertise obviously is in convective meteorology, and so there's this constant conversation in the background that's going on. You can see we're kind of typing to them saying what our thoughts were, and that we'd have to shift the message a little bit, and obviously saying that we within the bounds of what their outlook shows, we can kind of add some value, a little more detail, granularity to that, and downscale their outlooks, and so they were able to provide some confirmation from what they were seeing with some of their high-res guys they were doing some analysis with, and the traditional analysis as well sort of suggested that we were all on the same page. So this was about midday or so, and then looking from about noon into early afternoon, this is what we're dealing with at this point. You have this broad area where there's no cumulus that's developed yet at all, back within the kind of the old cold pool that's trying to modify. You've got deeper convection down in Texas, or I should say deeper cumulus down in Texas where the deeper moisture is. And then the western extent of this outflow boundary had pretty much stalled back into kind of the Archer County, Seymour, Texas area, and then up towards Vernon, Texas. And there were several attempts, you can see orphan anvils that had convection that attempted to develop even by early afternoon. So that may sort of, we were obviously in communication with our broadcast partners, and we were they were asking questions about, okay, they're seeing the same data and they're curious about how, what may happen as far as whether this would go earlier than expected or whether it would go later. And we were able to kind of say, based on what we're seeing, it seemed like it would be more of a later show. And we'll get into that a little bit more about what happened in Texas. But I did want to make the point too that the synoptic boundary by this time had made it down to the north sides of the Oklahoma City metro area from Stillwater, Oklahoma back to the west. And, just looking at the visible satellite tells you so much. And I could spend 15 minutes talking about all the features here, but I'll kind of briefly just go over a few that what we were kind of talking about in operations. We knew we had the convergence along the boundary. which was pretty important. We knew we were probably still not in the best shape as far as, recovery of that moisture depth and capping and subsidence that may have occurred behind the departing MCS in the morning. But we knew that we sort of had this blotchy, cellular, saucer type look to the cumulus, for lack of a better term, and that it was sort of flat and it didn't have a lot of vertical development. So that gave us some confidence that we wouldn't see convective initiation, but we got a lot of questions on that. We wanted to kind of know for sure. So what we did decide to do is launch a special 20Z sounding to help confirm that what we were seeing in satellite matched what what our thinking was as far as the convection that probably wouldn't develop in this area. There were a few echoes on radars. It wasn't very deep. You can see from the Twin Lakes radar here, kind of into Tulsa's area, a little bit east of Stillwater, there were some echoes on radar that weren't substantial, but they were enough to give us a little bit of concern. And this is after we had made the decision to launch the sounding. And here's the 20Z sounding. You see a razor sharp cap there, very pronounced elevated mixed layer. And you can see that in the water vapor too. You can see it in the sounding. That's one thing, a point observation, but to actually sort of outline that with the brightness temperatures that sort of really stand out here across central Oklahoma, this little corridor here, some of where the strongest elevated mixed layer is. On top of that, we still had the subsidence that was a factor from back behind the MCS as it departed as well. So we continued to message this. We continued to provide that deep level of analysis that sometimes our broadcast meteorologist partners, they don't have a time to do that as much. They're busy with so many things. We want to try to support them the best we can through NWS chat. So we talked about how the 20Z sounding did give us confidence that we're unlikely to see substantial convective development back to the north in the wake of the convection, that our focus was going to end up being further south. So we fast forward a little bit, get later into the afternoon, and we see that there was a little bit more development to the convection to the north, but we see that this continued bubbling of cumulus and these continued orphan ambles have been ongoing for quite a while now. By the time we're all the way up to about 20Z or 4 p.m. or so, we're still seeing that. But it wasn't the first few attempts that ended up going and developing into convection. Obviously, we're now an hour or two later, and we're still seeing this attempt at convection that's not really developing. One other thing too, I was kind of just wanting to point out too that you can see this deeper cumulus field, where the deeper moisture continues to move to the north into southern Oklahoma. What was really interesting, and I don't have a surface map to really show, but the dew points, they were up in the 70s or so, all the way into southern Oklahoma, and it was pretty uniform all the way up to Grady County and Oklahoma City Metro. By that time, the low level moisture had recovered a little bit. Maybe some evapotranspiration mixed in there too, but either way, the dew points at 2 meters were in the upper 60s to low 70s, pretty uniformly all the way down to North Texas. But I love using the total precipitable water product because it can show that there's more of a gradient there. So the moisture is really shallow on the north end, and it really shows with the total precipitable water how you've got the higher values that are down along the Red River and to the south. And that's co-located where we saw that the cumulus field was more extensive down there too, starting to work its way back to the north in that area that had been convectively overturned. So, we shifted the focus down into North Texas. By that point, we knew that boundary was going to be key. We talked about these numerous convective attempts and these orphan ambles, but we also kind of talked about how this it may still take a while, given the situation, given the kind of the background environment. There's not a lot of large-scale scent moving in. It's going to be driven by sort of this mature mixing and development of convection along the convergence boundaries. And so we really wanted to try to make that point by around 4 p.m. or so. A lot of anticipation, obviously, of people thinking that there would be some convective development. With some uncertainty, we wanted to try to clarify that some. The day cloud phase, really, especially for the younger forecasters, less experienced forecasters, I think it's really key for them to really see in just a glance where these orphan ambles, these convective attempts are. Really important to use that, even for the veteran forecasters, but certainly for the developing forecaster, I think it really helps tell the story there, where they can separate out some of these glaciated areas with the convective attempts. But you can see here that we continue to not have much cumulus at all from around Wichita Falls area, Henrietta, Texas, Puerto Rico, Oklahoma, and this area here that's still convectively overturned. It's a little bit behind. They're not quite modifying. They're obviously it's pretty unstable there, but it's just not as unstable as back to the west, where we're pretty deeply mixed. But you see the convective inhibition and the SPC mesoanalysis erodes with time. By the time we get to 21Z or so, it's mostly gone by that point. So we know that we're probably pretty close to convective initiation. But there was convective inhibition all the way until about 19 or 20Z, at least per the RAP analysis from SPC mesoanalysis. And we tried to summarize all that, but we want to kind of also talk about how it still seemed like it'd be sort of more of a very late afternoon type scenario that we may still be another hour or so before we really get sustained convection along that boundary back in our western North Texas counties. Really, it just is so intriguing to me to get involved with the folks involved in the development of Warren on Forecast. And some of the products that come from them are really useful, and we're starting to integrate those more into operations. But by this time, the Warren on Forecast system had really sort of keyed into that boundary, and its convective initiation with this paintball type appearance here of where it shows convective developing within an hour or so really started to show up along that boundary. So we'll talk a little bit more about the Warren on Forecast system going forward. But I want to spend a little bit more time on this slide. Again, hopefully the animation is slow enough to where on your end it comes through pretty well. But you see these convective attempts, these orphan ambles that continue. And this is a fairly long duration loop. This is about 18Z now where it's at. But I wanted to show how powerful it is to have observational data too overlaid with that, where you have the surface observations. You've got a lot going on here. There's some early on, there's some, let's see here, let it loop again. But anyway, early on, there's kind of this cross-hatching look where you've got some billows and some stability that is present here. If this were a faster loop, you'd be able to see that transition with time a lot quicker, but horizontal convective rolls develop by the time we get deeper into the afternoon, which is a clear indication that we're becoming much more unstable there. So you can see so much from satellite. You can assess stability, you can assess the shear just based on the orientation of the horizontal convective roll. So many neat things you can see from just visible satellite alone. Older veteran forecasters know this. Obviously as meteorologists, we all know this, but sometimes it just takes getting back to the basics and really focusing on this stuff to see how much you can see from just visible satellite alone. And you can see by the time we get past 21Z now, we're starting to see some convection that develops in this area here around Vernon, Texas, along the Red River. But the concern is, though, and I'll let this loop back through just one more time real quickly to catch the front end of here, because I want to make the point that we didn't have cumulus development early on where we had the cold pool that extended all the way back to the west here. And it took a while to modify that. And we know that sometimes that can be pretty dangerous from a tornado standpoint, that if we can get a thunderstorm that can sustain across the boundary and get into that more stable area, that that as long as it's unstable enough for the convection to continue to be fairly intense, that sometimes your low-level shear is quite enhanced here. Now, we knew that we wouldn't have to necessarily deal with that too much as far as from a standpoint of early afternoon through mid-afternoon shear being particularly strong. It would take until the low-level jet kind of kicked in later on. But the combination of us, kind of having this cold pool that had been modified on top of that, anticipating a low-level jet kicking in the evening, that's Plains Tornado Forecasting 101, is knowing we've usually got that 1, 2, 3 hour window where we haven't decoupled in the boundary layer, so we're still unstable, but yet we're starting to decouple just enough to where we can get the low-level jet, and that low-level shear juxtaposes with the significant amount of instability. So, but you can see all that again. You can see that evolution in such detail with the satellite data, the 1 minute data that we have here. But yeah, you've got the hot, deeply mixed air that's back to the west of the dry line that's sharpening up. Really key here, I think, was the orthogonal flow that you see with these horizontal convective rolls with time that become a little bit more orthogonal to the boundary. And so that's kind of one of those things where the parcels tended to train. They'll move off the boundary pretty quickly, so they don't have a lot of residence time. Sometimes dry lines and boundaries that are more parallel to the low-level flow can have that residence time of the parcel within that dry line or that boundary circulation, and that can result in some earlier convective initiation. But in this case, we didn't have that. We had these parcels that were detraining off into the area that wasn't quite as unstable. So there's a lot to see here. We talked earlier about the billow clouds that transitioned into more of a kind of an unstable look with time too. So we want to try to consolidate that. Based on the trends in the satellite, we took a stab at it and kind of highlighted an area that we thought was most likely to see convective initiation over the next hour or so in that 4 to 5 p.m. time frame. We wanted to kind of translate that into actions a little bit. I know Dan Halbletzel at the Nashville office has really been leading an effort to say, hey, we're doing all the science, but we need to try to find a way to transition that into messaging that's useful to our partners and to the public. So we want to kind of transition to that a little bit this season and highlight that with some of these newer graphics we have. It's all about sort of taking the science and finding ways to translate to basically a better messaging. But yeah, just talking a little bit more about these situations where we have these horizontal convective rolls that may be oriented a little bit more normal to the dry line. Is usually when you have convective initiation that's it's a little more likely to occur earlier, whereas you may struggle a little bit if it's oriented a little bit more orthogonal to it. So that's kind of goes back to some of the early work with the dry line, you know, Hain et al. 2001, really interesting concepts. It's important for the forecasters to know. Whoever's kind of doing the mesoanalyst roles, it's really important for them to know that. And the same goes for some of these cloud lines back to the west. Sometimes that can indicate where you have a little bit of an opportunity for convective initiation, would be where the cumulus is enhanced, where it sort of meets or intersects the dry line or the boundary. That can often be an area of convective initiation. These are things that models typically won't see very well. In the future, they'll probably be able to assimilate some of that a little bit better, but as it stands right now, that's a little bit difficult for the models to see. One thing I'm interested in, I don't have a lot of answers here, so would certainly be interested from anybody that has a lot more expertise in satellite interpretation than I do, but it seems like you have these areas in the vegetation RGB here that kind of shows that there may be a little bit more heating of the land surface use, maybe just some more open fields or whatnot. And it makes you wonder in some scenarios, I'm not sure if it really played a role in this scenario, but certainly some scenarios where you could have sort of an enhancement and may sort of focus some of the convective initiation along those boundaries, where you can have maybe a little bit of a very small scale differential mixing that goes on between where the land, depending on its use, is heated more open fields versus more vegetated type land. So I found this fascinating. I really want to watch this maybe going into the next season to see how much utility there might be here. But you can argue maybe some of this convection right here west of, sort of in the south of Childress and west of Knox City, Texas area may have been sort of the impetus for some of this cumulus development here at the edge of some of the better moisture. It's hard to say, but certainly would love to have a conversation with some of the folks that are more adept at satellite interpretation than I am. But yeah, just going forward, we talked about the low level shear already. You can see 0 to 1 kilometer shear on the left here. Pretty weak throughout the day until we get to that 2 to 3 Z time frame, and it really ramps up. The same for the storm, or the significant tornado parameter as well. You see the values that become pretty large during the evening. And this is what we saw: very weak, low level shear, pretty good, decent deep layer shear, and quite a bit of instability at 21 Z. And the hodograph enlarges quite a bit by the time we get past 0 Z and into the 0.3 Z time frame as the low level jet ramps up. So just another perspective to see that from a forecast sounding standpoint. And also, don't forget to take advantage of our observations from that we have, say from the radar, for example, for BAD1 profile data. Excellent source here from autumnsky.us, their BAD1 profile data. It's available from the WSRDADs. You can really kind of latch on to when you start to see that increase in low level shear. Pretty important tool. In this case, it seemed like we had a little bit of elongation of the hodograph that showed that maybe it supports some good venting, Hanville layer flow that would support some very large hail. And indeed, we actually had 5 1/3 inch diameter hail from the initial thunderstorm that developed. From you see all the convective initiation of the earlier satellite images. So that was really impressive. Something that the Warn on Forecast system does an increasingly good job at being able to latch onto that and give confidence to the forecasters of what they're seeing in their analysis. I think that's a very important part of Warn on Forecast going forward, at least in its current state where it's at now. You see these signals in the Warn on Forecast storm scale modeling, and it can validate your analysis. It can give you confidence to go ahead and act on that, whether it be sort of a warning environment or in mesoanalysis and the messaging that you're trying to communicate. And you can see Todd did just that here, talking about the hail threat with the left split and sort of the cluster that ended up being on the northern end of this cluster here. So really interesting and exciting stuff coming from the folks at Warn on Forecast. But you just can't let go of the traditional analysis here, satellite-based analysis, and really focusing in on these cloud formations that you see and the patterns that you see in visible satellite RGBs. Powerful stuff, and we need to, at the WFOs, really be tuned in on that and focused on that. It's really important. So hopefully this loop comes through pretty good. I went ahead and did a fast loop so you could see some of these features evolve a little bit quicker. You can see the orphan ambles eventually result in convective initiation around Frederick or just to the southwest. You see the crosshatching and sort of the billows that transition into the horizontal convective rolls west of Lawton, Oklahoma here. Just amazing if you do a longer loop how much you can see the atmosphere transition and how much information you can get from that. So I'll leave these main takeaway points up here. You know, I think probably one of the main ones I wanted to put up top was to say, hey, don't overcomplicate this. It's actually, if you just understand the physical processes within the atmosphere and apply that knowledge to what you see in satellite meteorology and in the observational data, you can communicate a lot of useful information to our partners and the public. And I think we're all used to doing this, but I think exercising that skill and really trying to refine that, maybe sort of a seasonal readiness sort of way before you get into the convective season, is pretty important. And we know that for a high quality DSS, that has to be rooted in these good conceptual models, you know, to be a good analyst of what you're seeing in satellite data and observational data, and then trying to find ways to message that through NWS chat. And, you know, taking advantage of some of these emerging tools such as Warn Forecast and machine learning and AI as it continues to mature and gives us a good starting point. Who knows where it's going? You know, the science is exciting to see where all this information is going, but you know, it's certainly exciting that we have the data that we have now. We can just integrate that and provide the services that we can. So that's really all I have. I guess we can probably open it up to questions now. I don't know. We'll see kind of how, if anybody wants to type any questions in, I'd certainly be more than happy to answer those.
Yeah, thanks, Randy. At this point, we'll take questions. I'll unmute everybody. If you're connected via phone, I believe you still need to unmute yourself. So you could either type in your the question to the question box or just speak up.
I guess I'll ask a question. For this event, do you recall how the GLM was used? It's a fairly new, it takes some time to get used to the data, I think, but and there wasn't a lot of convection beforehand, but as it developed, how was the GLM used?
Yeah, the GLM, as I recall for this event, I remember it was pretty helpful. I think I'm trying to think. I know Phil Ware is one of our excellent forecasters that we have. That, you know, I consider him our lightning expert, and he's really provided us with some great material and helped us understand how to integrate that into operations better. But I think really focus on the flash rate and things like that, I think, are certainly important with that. But I don't recall specifically with this event. I know we've had other events that we've had this past convective season where, especially once we got into the summer, that we were able to use that quite extensively. So I find it pretty useful. I don't claim to be an expert in it, but, you know, I hope to kind of continue to work with Phil and others that are an expert in that area to integrate that into not only mesoanalysis, but warning operations as well.
Thanks.
Hey, Randy, it's Brian Mata. If you could go back to one of your loops. Okay. Yeah, that one I think will work.
I can go back to the visible if it's better, just because I think it's slower.
No, this one's fine.
Okay.
So up to the north there, you just didn't mention it, and I just wanted to see if you had any comment on it. There's some mid and upper level clouds that you see coming in from the west there. Looks like a mid-level jet streak. You just didn't mention it, and I was curious as to why.
No, that's an excellent point, actually. You know, sometimes, in this case, going back and looking at it, I question whether maybe we did have some small-scale sort of ascent that may have been kind of working in the area there. That I think on the overall, there wasn't a lot of strong ascent that was coming in. It was sort of just this flat jet, or this, you know, this flow in the mid-levels that was fairly strong, but there wasn't much as far as a discernible shortwave trough in there. I kind of wish now that I would have shown maybe some of the more of the water vapor imagery, but we didn't archive the CONUS view, so we only had the mesoscale view. So this would be a fascinating case to go back and look at that a little bit more. But I think that's important. You see the cirrus coming in, you know that at the very least that you've got some fairly strong flow aloft, and so your deep layer shear is pretty intense. Now, whether that signals that there may be at least a little bit of subtle forcing for ascent and a minor shortwave that may be embedded within, I think that's certainly probably the best indication we're going to get of that, is to see some of these little areas of cirrus that kind of flow eastward in the flow.
Okay, thanks. I just wanted to make sure about if I was missing something there or not.
Yeah, I think it's just one of those things where there's so much to really look at here that if you stare at this for 5-10 minutes, there's probably other little small features too that really show up. I mean, I've been fascinated with this little feature right here. I don't know if you can see with the outline of my cursor, but there's there's a little bit of kind of a sharper edge in the Q, where the cumulus kind of just diminishes a little bit with eastward extent. Like there may be a little bit of mesoscale substance or something that works kind of west to east across the area, and it results in kind of this sharper area here you see in the cumulus field. There's so many things like that that I can't really totally explain, but I think it's important as a meteorology community for us all to kind of, work with the satellite experts that are sort of expert in the interpretation of this sort of thing. I think that's it's really key in mesoscale meteorology.
All right, very good. Thanks.
Randy, we have a question from Jenna Lake. As far as the vegetation, with sufficient heating, do you think that local evapotranspiration maximums could lead an additional density boundary, could lend an additional density boundary to convective initiation?
Yeah, I think so, especially when you're in these situations where you're not looking at a lot of significant forcing aloft, and you kind of live and die by the boundaries, because that's pretty much where you're gonna have an opportunity for convective initiation. I think that's very important. So I was trying to go back to this a little bit. Maybe we can just kind of look at this for a second to see if there's anything that really shows up in this veggie RGB, which there it is. I mean, I think that's really important, especially for our western counties. We have some areas that may, receive more precipitation or more convection than other areas, and I think it's important to keep track of that, because right at the edge of that, you may have more evapotranspiration, whereas you don't. That may have a drier area that's up next to that. I think there was a publication from a while back that talked about how some of the fine lines on radar couldn't be explained from a process like a true dry line, but there were actually these differential heating boundaries that may have occurred in these areas that had different land use, or that may have had some areas that had more rainfall recently and more evapotranspiration. So yeah, I don't know. Maybe you guys have some insight into a better product, or sort of a better way to look at that or assess that. But to me, I haven't looked extensively at this product, but it seems like there's some value to that, to see that sort of thing.
Yeah, I agree. One product that I've advertised in some of the trading is the LISP data, the land surface data set that various land surface fields you can look at. Chris White from the Huntsville office makes this available to AWIPs so you can view at the local level. So that's one of the things that's available out there, and there's probably some others out there as well. So yeah, looking for those type of boundaries, those, like you said, differential heating type of boundaries can be very important as well. Any other questions or comments from anybody?
Hey, Randy, this is Todd. Excellent job as always. And I did come in about 10 minutes late, so you may have addressed this up front, but even though it doesn't directly apply to the use of satellite in this case, this case did occur during the pandemic. And of course, the onset of telework was early in the spring, and we didn't have a lot of time to prepare for that here at Norman. I was curious if you addressed that at all, about kind of how we adopted telework into our severe weather operations, and kind of that process. Might provide a little context.
Todd, I'm glad. Oh yeah, no, I'm glad you brought that up, because I didn't get a chance to get too much into kind of how our operations was structured. But no, that's a big issue, and we've dealt with that, of course, all through the spring, like all the other offices have. And I think it worked out really well, because I showed some of your sort of chat messages where you were kind of keeping up with the warn-on forecast. But what I didn't say was that you were actually not in the office at the time, so we were having to leverage our telework to accomplish that. So Todd was feeding this information from what he was seeing on the warn-on forecast output to sort of back to some of us who were looking maybe a little bit more intensely at the satellite data and some of the other observations, and our warning forecasters, all who were actually in the office. But I think on this day we only had, I'm trying to think, I think we only had four people in ops, but we had so much excellent support from our MIC, from our WCM, our SU, and a couple of our other forecasters on telework using Google Chat, that we were able to sort of stay in contact with them.
Yeah, I would just, add to that exactly what you said, really. We were operating with the bare minimum as far as warning operations in the office. But what we found was we could actually have even more people involved and engaged in the event remotely from home, and they were very siloed in their duties. For instance, I was interrogating the Warrant on Forecast system and communicating that through chat, whereas other people were solely dedicated maybe to one television network for broadcast monitoring, whereas, you know, under ordinary circumstances, we would all be congregated in the office and one person may be monitoring all 4 television broadcast networks, you know, and we might be really operating even thinner. It really gave us an opportunity to really focus in on the specific task. So like earlier, I think it was Scott that asked about GLM. If Philip happened to be in the office this day, which I don't remember if he was or not, he was probably very dedicated to that and maybe just passing the most relevant information on to Randy. And, you know, people stayed very task focused during this period.
Yeah, I think that's an important point, Todd. Just to add a little bit to that too, I think it's, I was really impressed with how it worked. I know sometimes, and we do an excellent job in our office, I feel like, of doing this. We have excellent leads, management, and kind of guides us the right direction. And so this typically isn't a problem, but occasionally it's just the nature of our job that I think mission creep can kind of get in there a little bit, where sometimes you're focused on this one thing, but there's something else that has to get done. So you end up kind of diverting into that just a little bit. Whereas I almost found it this season where maybe there was a little bit less of that, because just the way we were able to organize and leverage the teleworkers, we were able to stay focused in kind of our section of what we were the ones to focus on the most, if that makes sense.
Okay, any other questions or comments out there for Randy?
I just have a question on that RGB for the veggie that you were showing. What product was that? I couldn't quite tell.
I believe that was the way it's labeled in AWIPS, if I recall correctly, is veggie RGB. And that's, there may be another, I don't know if the title is, yeah, it's a newer product that I haven't paid attention to very much before now, but I believe it's veggie RGB. So I'm not sure where it originates.
Thanks.
Okay, any other comments or questions? Oh, hearing none, we want to thank Randy for a great presentation. And a reminder, I'll put the recording of this up later in the day. It'll include the PowerPoint, so you'll be able to look through all the 1-minute imagery on your own. If you have a interesting case, particularly a mesoanalysis case that you'd like to share with the community in the future, just let myself or Scott know, and we can set you up with one of these webinars in the future. Thanks, everybody, and have a great day.